Good day and welcome to this tutorial. In our previous tutorial we looked at how we could connect the charge controller, the battery and of course the solar panel together. Now in this video we're going to be looking at the importance of protective devices as we connect our systems. It is very important to select and install an appropriate overcurrent protective device that will prevent the damage or system failure. We're going to be connecting the four major components together. It is necessary that you connect a protective device. In our previous videos, we've looked at the various connection of these various components. So we're going to be concentrating more on the connection from the solar panel to the protective device. The protective device is meant to control the overflow of current from the solar panel to the battery. So we're going to connect the terminals of the protective device to the terminal of the charge controller, the positive and negative terminal, as we have seen in our previous videos. As you can see here, so the positive and negative terminal will be connected. The protective device would help control the flow of current from the panel through the charge controller to the battery. So we're going to be connecting the battery to its positive terminal and negative terminal from the charge controller. Then of course to our various loads, in this case a DC load. We're using a DC bulb. So we connect it to the DC load terminal. You get the positive and negative terminal from the charge controller, as we've seen in our past videos. For those of you who haven't watched that video, please do. Also, just as we've seen the case where we have AC appliances which are to be connected to the system, we then have to introduce the use of an inverter, which is also a very sensitive device in solar PV installation. Now we said the inverter would convert the DC from the battery to AC in order to supply the appliances, and we've also looked at how much we could actually use the inverter. Aside from connecting source from the solar panel, it also gives us the ability to be able to connect it to a national grid supply and as a hybrid system. So we're going to be connecting the battery to the inverter, as we've seen, as you can see here now, and also we could actually connect the inverter to AC supply of any national grid, whether a backup generator or a backup generator. So it is also very essential that you use protective devices when you want to connect from the inverter to your various AC appliances. It is also very important to connect protective devices at this junction as well. Now we're going to be connecting the protective device to the inverter plug, and of course from the protective device to the switchboard, where it will serve as our distribution point. As you can see, connecting the positive terminal of the protective device to the switchboard of the various AC appliances, and the negative terminal as well. Well, in our previous videos in the past, we've looked at how these connections were made. The most essential part of these lecture, of course, as we discussed earlier, is the connection of the protective device and why it is important to connect the protective device to these various appliances. So we are still trying to connect the various appliances to the switchboard, as you can see. So this is just to show the various junctions at which you can actually put a protective device in order to protect the system. And of course, there will be need for an eting of the socket outlet. So we've been talking about protective. What are these protective devices? The protective device is the MCB. It is the miniature circuit breaker. It is an electronic switch that is automatically controlled to protect an electrical circuit from excess current flow, that is overflow or short circuiting. A central function is to interrupt the current flow until a fault has been found. Now, there is a difference between the AC MCB and that of the DC. The AC will have an AC signal sign, a sinusoidal sign on the label of the MCB, while that of the DC will also have its this direct current sign, and of course the positive and negative terminal, uh, input and output terminal. So this is the major difference between that the AC and the DC miniature. So when connecting the solar panel to the charge controller, we use a DC, which is using direct current, and of course when connecting that of the AC part, we use an AC circuit breaker. This brings us to the end of this video, and please do not forget to hit the subscription button, and of course turn on your notification for when next I post a new video. Thank you.